class. In this video, I'm going to be talking about molar conversions. Now, what I mean by conversions is one unit changing into another unit. For example, in the case of this, I'll be asking for how many grams are in a certain number of moles, where I give you moles and ask for grams. Or I could give you grams and ask for moles. So a conversion is that change between different units. By molar conversions, we will be referring to the mole as well as molar mass and what those mean in order to convert between grams and your moles. This is a video of part 1, so there are a lot of pieces that go into molar conversions. This is just one piece that we'll be looking at. I'm going to focus it in just to get the basics down first. Now, in order to understand completely this details, you do have to know what molar mass is. I have a video called The Mole and Molar Mass. If you have not had a chance to watch this and you're a little fuzzy on what the mole is or how to calculate molar mass, please go see that video. You will need an understanding of this information of what the mole is, what molar mass is, in order to fully be able to do molar conversions. You have to be able to calculate molar mass in order to convert between grams and moles. However, for the sake of this video, in order to save time, I will give you the molar masses already, so we don't have to waste time calculating them in this video. I want to just focus on the process of molar conversions. If you don't know how to calculate molar mass, here is your reference video. Also, we have seen conversions before. I'll be talking about conversion factors and the factor method that we saw earlier on in the year. Another video to refresh your memory on canceling units, on what conversion factors are, would be my video on density as a conversion factor. This was one we had way at the beginning of the year when we first saw conversions. I will be reviewing some of those general basics again, but if you need a reference to be like, all right, I've got to start from square one, this is a good video for starting at square one. Without further ado, let's go ahead and move on into my process for molar conversions. First, quick review of what molar mass is. We talked about that molar mass is the mass for 1 mole of a substance. And when I'm referring to a substance, I'm referring to elements. I could be referring to compounds where they have multiple elements together. I could be referring to molecules. Most often molecules are your nonmetals and nonmetals together. I could also refer to formula units. These are used for when metals and nonmetals get together, so these are your ionic substances. Your units. We are caring about grams because that's our unit of mass, and this is for 1 mole or per 1 mole. So verbally, I will say grams per mole as the units of molar mass. I will abbreviate this on paper as grams. I will use the diagonal division sign per and then mole. So this means mass for every 1 mole of a substance. Let's take an example now. So carbon has a molar mass of 12.01. Those units would be grams per mole. To dive into a little bit more about what this means, I could say that this is 1 mole of carbon has a mass of 12.01 grams. That is one way to interpret grams per mole. I could also say 1 mole of carbon weighs 12.01 grams. Again, molar mass is a relationship between the mass and moles of a substance, how much something weighs. Now, I can take it a step further, so these are kind of long, drawn-out sentences. I can abbreviate this by writing this as a fraction. So if I said that 12.01 grams is equal to, or weighs, or is the amount of 1 mole, then I have a fraction for that sentence. I could also just as easily have said 1 mole is equal to, or weighs, or has a mass of 12.01 grams. So in this case I have 12.01 grams divided by 1, whereas here I have 1 mole divided by 12. They mean the same thing. These are fractions, mathematical symbols to represent this sentence, the mass of 1 mole of a substance. Now, as we write these as fractions, we called these fractions earlier on in the year conversion factors. So your conversion factors are fractions that we use to relate two different units. In this case, we're relating grams to moles. Okay, I think I've beaten that horse dead. Let's get into some calculation examples. How many moles are in 7.98 grams of carbon? First, I want to write the molar mass of carbon as a fraction. Well, this is carbon, this is also carbon. I have already done that for you. So first, let's write those as fractions, which I did. Next, let's identify the fact. So your fact is the number that we're starting with. It's the information that we're given. It's what we have to start with. In this case, I have 7.98 grams of carbon. This is the only number I'm given. This is the only numerical value. So in this case, it is obvious that this is the fact. So I'm going to start with my 7.98 grams of carbon. In this question, I'm starting with my 7.98 grams, and it wants me to determine how many moles. So in this case, I'm starting with units of grams and trying to convert it into units of moles. I don't want to stay in grams anymore. I want to cancel my grams. So in order to cancel my grams, I need a factor. To cancel units, recall from earlier on in the year that they have to be located in opposite locations. For example, this is on the top. So if I want to cancel it, I need the same unit on the bottom. If something was on the bottom and I want it canceled, I need this similar unit on the top. They cancel diagonally, top to bottom. So here I've got grams on the top. In order to cancel my grams, I would need the unit grams on the bottom. So if I look up to my conversion factors, I've got 12.01 grams here over 1 mole, or 1 mole over 12.01 grams. Well, this is the conversion factor that gives me grams on the bottom. So this is the one that I'm going to use down here. So I'm simply going to rewrite this conversion factor here, because now I've got grams that cancel with grams. The unit that does not cancel is moles. So that is the unit I am left with. To get a numerical value for this, I'm going to times everything on the top and divide everything that goes down. So to plug this in, I would say 7.98 times 1, well, that's going to not change my number. It's still 7.98. So technically, all the ones that you see where they're by themselves, you can ignore those because they don't change our number. So I'm going to ignore that. 7.98, it goes down, so divided by 12.01 equals, I get 0.664. My unit is moles. I am going to specify that that is of carbon. When you report your answers, you should have a number. So that is what you get with your answer from your calculator. You should have your unit. So in this case, our unit is moles and not grams. And we should have our substance. And we've been talking about carbon as our substance. So when you report your answer, please tell me the number of your answer, the unit that you have, and the substance you are referring to. Example 2. What is the number of moles in 100 grams of MgO? The molar mass of MgO, which is magnesium oxide, is 40.305 grams per mole. I would like you to try this example on your own. Consider what your fact is. Consider how you would write your factor in order to cancel the units and end up in what the question is asking for. Go ahead and pause the video. Try this on your own. All right, welcome back. Let me go through my answer. So first, I wrote out my molar mass as a fraction, as two different fractions. Again, we could write this as 40.305 grams over 1 mole, or we could say that 1 mole has a weight of 40.305 grams. My fact is my 100 grams of MgO. So I'm going to start off with my 100 grams of MgO. I would need to cancel my grams, so in order to do that I need grams on the bottom of my factor. Therefore I would use this fraction here on the right side. So I would have 1 mole over 40.305. And then to calculate my answer, let me check. It's asking for what is the number of moles. So here's I've got grams to start with. Here I canceled my grams. The unit I am left with is moles. So I am left with the unit it was asking me for. To plug it into my calculator, I would do 100 divided by 40.035, and I got 2.48. Again, you need to include your moles, so that would be moles. It is a good habit to get into writing out the substance that you are referring to, so MgO. Let's look at the opposite process. So in this case, what is the mass in grams of 1.20 moles of CO2? And I'm giving you molar mass of CO2 is 44.01 grams per mole. The only difference is that now it's asking for mass, what is the mass, and it is giving me moles. So in this case, I am starting with moles, trying to end in grams. Again, I'm going to write this as two different fractions. So 44.01 grams of carbon dioxide is equal to 1 mole, or I could write this as 1 mole of carbon dioxide is equal to 44.01 grams of carbon dioxide. So those are my conversion factors. Those are my fractions to choose from. My fact is my 1.20 mole of CO2. I do not want to stay in moles. I instead want to convert this into mass, which is in grams. So to cancel moles, I want the unit mole on the bottom. So which of these am I going to use? Well, this one here has moles on the bottom, so I'm going to use this one right here. So 1 mole on the bottom, that would put my 44.01 grams on the top. In this case, I'm going to be multiplying my 1.20 times 44.01, and the reason why I'm multiplying is because these are on the top. So, you can't see that, 1.20 times 44.01 equals 52.81. And then I'm going to include that this is referring to CO2, carbon dioxide. Similar steps that we follow, I'm writing our molar mass out as 2 different fractions. I'm identifying what my fact is, and then I'm picking which of these fractions I would use in order to cancel the units of my fact to end up with what it's asking for. So let's try one last example. Example 4. If a reaction requires 25 moles of oxygen gas, something to notice, oxygen gas is O2. This is one of your diatomic elements that Brinkelhoff, the I brought clothes for our naked Howard, the Magic 7, those 7 elements, be mindful that you do have a 2 as your subscript. So your molar mass is not quite directly off the periodic table. It's not the same as just an oxygen atom. Okay, if a reaction requires 25 moles of oxygen gas, then what mass in grams of oxygen is needed? And then I gave you the molar mass of oxygen is 32 grams per mole. Again, that's double what is shown on the periodic table because of this subscript. Go ahead and take a moment, work this out on your own. Okay, welcome back. I'd like to go over my answers now. So my 32.0 grams per mole, I wrote that out as 2 different conversion factors. So 32 grams is equal to 1 mole, or I could say that 1 mole is equal to 32 grams. My fact, I started with my 25 moles of oxygen gas. So 25 moles of O2 is what I start with on the left side. I don't want to stay in moles. I want those units of moles to cancel. In order to cancel, right now they're on the top. Therefore, I need them on the bottom. So I would need this left conversion factor because moles is on the bottom. So there is my left conversion factor, 32 on top, 1 mole on bottom. In order to get my answer, first, let me just double check. Moles here cancels with the moles here on the bottom. I am left with grams because those do not cancel out. So to get my numerical answer, I would have 25 times 32.0, and that would give me 800. My unit is grams, and I'm going to specify that that is of O2, oxygen gas. Now, at the very beginning of the video, I said that this is part 1. We are going to get a couple more steps in mole conversions, and we will see our molar conversions show up again in a later unit. So I am going to give kind of a brief mole map of what we just talked about. If we are starting in grams, and again, that's mass. So if I have my mass, most often in grams, and I have moles, in order to convert from grams into moles, or if I'm starting in moles and trying to convert it into grams, for this process, grams to moles, I will use my molar mass as the conversion factor. We will build more onto this map, but right now, that's all we've learned, so that's all I'm going to show you. Hope this was helpful. From this video, you should be able to convert from grams into moles and vice versa. Thanks. Have a great day.